Hi, thanks for your interest in trying Chapel. If you'd like to look at this Chapel October 2023 tutorial repository, the easiest way to do so might be using a GitHub Codespace. GitHub Codespaces let you create virtual development environments in the cloud, complete with a Unix system and a Visual Studio Code editor. The Chapel Codespace, based on this repository, also contains the Chapel compiler and the various editor tools to work with the language. This should get you ready to play with Chapel programs and experiment with the language. Now, although GitHub Codespaces are a very convenient way to get started, they don't have the best performance. So if you're looking to adequately assess Chapel's performance on parallel or multi-node systems, you might be better off creating a local installation and following instructions in the README below. However, to get started, it's sufficient to open this repository and create a codespace by going to this Use this Codespace button. There, by clicking Open in a Codespace, you'll be taken to a new screen, which will contain the GitHub Codespace editor. It will take a little bit of time to load because what's happening under the hood is that a new Docker image is being spun up and a new container is being created that contains the files from this repository as well as the language tooling and so on and so forth. I'll talk to you when this finishes. All right, here we are. The codespace has been spun up, and the very first thing you should see is the README file, which is the same README file as you would have seen on the GitHub repository. So Visual Studio Code opens this by default in plain text, so you're looking at the raw Markdown code. And although Markdown is supposed to be human readable, it's nicer to look at the preview, which you can do by finding this button in the top right here, called Open Preview to the side. By the way, I'm going to increase the font size a little bit to make the Visual Studio Code window easier to see. So now you can read this README file, which includes links to various slide decks that introduce Chapel. So the 01 hello.chapel, so all files really prefixed with 01 are used and described in the Introduction to Chapel slide deck. All files prefixed with 02 are introduced and described in Chapel Basics, which is another slide deck. So you can step through these slide decks and look at various pieces of content on Chapel. And to get started actually compiling and running Chapel programs, we can use this terminal down here, as well as any of the programs listed here on the left. So the very first program anyone ever compiles is Hello World, and I'm going to open this in full screen. So all this does is print the words Hello World, which in Chapel is just a single statement. To compile this program, you use the command chapel or chpl, and give it the name of the file that you want to compile, in this case, hello.chapel. When the compiler finishes, you can just run the program, which will be named the same thing as the file, except without the .chapel extension, and get the results. So some files in this repository are actually intended for multi-locale execution. And in Chapel, locales typically refer to something like nodes in a cluster. So if you're running on a system that's distributed and has multiple nodes, like a supercomputer, you might have more than one machine, and all these machines are networked together. So because we're running in a Docker container, we actually can't do this for real. We can't actually find another machine, connect to it, and communicate with it. But we can simulate this and look at what it would look like if we were running the programs on multiple locales. So this would not give you a representative performance improvement because you're still using the same amount of computing resources, and in fact, you might be spending more time pretending that there's two machines instead of one. But it definitely does a nice job of demonstrating what programming a multi-system or multi-node system in Chapel looks like. So to do that sort of thing, what you have to do is set the Chapel com environment variable to be equal to gasnet. So I will do that now. After this, you can compile programs as before. However, when the program is to be executed, you will need to specify the number of locales. So if we weren't simulating a multi-node system, then this would literally tell Chapel how many nodes to connect to and set up on. But in this code space, all it will do is tell Chapel how many nodes to simulate. So now if I run 01 hello, I won't be able to do that because I have to specify the number of locales. If I set an NL argument to be 1, I would effectively be running this program on one node as before, but I can also run it with NL2. Now, because hello world.chapel doesn't have any code that intends to distribute the code across multiple locales, and because write_len is just a single function, it doesn't make sense to distribute it. So running hello with NL2 does nothing differently than running hello with NL1. However, we can look at programs that do behave differently, such as hello dist node names.chapel. So this is a more complicated program, and there's explanations of a lot of these concepts in the slides, but what it really does is loop over all of the locales or nodes, and from this locale create multiple tasks or as many tasks as the node supports, and print hello from that locale and task. So effectively, this will use every core on every available node to print hello. So if I compile this now, that would be hello dist node names.chapel. And then I execute this program with NL1. I will see only one line of output, hello from task 1 of 1 on codespace blah 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 0. And if I run this with NL2, I will get 2 lines because 2 nodes are being simulated. Now, I said that it would use all cores on all nodes, but we're only seeing 1 line per node. This is another limitation of Codespaces. They are relatively underpowered machines and don't support a huge amount of parallelism. So although they're nice for testing out Chapel, they definitely don't have the multi-core support that even your laptop would have. So if all of this looks interesting or promising to you, consider installing Chapel on your local machine and trying again to really push the performance that you can get out of your computer. From here, like I said, you can go back to the README file. I will preview it again and go through the slide decks to learn more about the various features of Chapel. In particular, the 3rd and 4th slide deck include information about parallelism. Thanks for your interest again, and I hope you enjoy using Chapel.